Alright, welcome back students. So in this part, we are going to discuss all about trilaterations. So trilateration is another method of horizontal control point establishment and densification. It is employed over large areas where the methods of traversing would not be expected to maintain a uniform high accuracy over the entire area. So again, so the trilateration is dili siya gamito ni siya no kung if ever si um, traverse or the method of traverse is not possible no or dili na niyo ma-maintain ang high accuracy over the entire area or kanang sa isa ka location. So it consists of networks of geometric figures with all the sides measured directly in the field. So unlike sa triangulation, so sa trilateration, ang gina-measure na pud ani sa during sa pag execute sa triangulation is ang trilateration is sides, no? So dili siya ga-deal sa angle. The angles are computed from the measured length. So instead, ang trilateration nga method, so i-measure mo na to ang distances. So out from that distances, we can now determine the angles, no? Inscribe mga angles, no? Triangulation, angle lang naa, then ato ang i-calculate ang distances. So it is considered to be the most accurate, no, among the three methods because distances are measured more accurately than angles. So we all know that nga mas accurate kung sides atong gamiton, no, compared sa angles. Kumito ng as long as kung pwede siya solved into cosine law. So cosine law siya kay tungod sa kung mogamit ng sine law na ay discrepancies nga mahitabo. So advantage of trilateration is ang checks niya can be made in calculation while moving through the system by more than one possible route. So the cosine law is the trigonometric basis for trilateration. So the cosine law, let's recall that if the three sides of the triangle are known, then the three angles can be computed. Sabot, kung naitulo ka, given lang tulo ka sides, so makompute na to ang mga interior angles ani nila. So let's say for example, given ni si A, given si B, and given si C. So makuha po na to ang iyang interior angles A, B, and C. So ang formula sa cosine law, no, kabalo naman siguro mo ani. So C squared is equals to A squared plus B squared minus 2AB cosine C. So and for the other side, so kung kintahay B na po atong kuhaon or the angle B atong kuhaon, so kani nga formula atong gamiton, the second one, which is the B squared is equals to A squared plus C squared minus 2AC cosine B. And kung gusto na po natin kuhaon si angle A, so we're going to use this formula, A squared is equals to B squared plus C squared minus 2BC cosine A. Alright, so once the angles are known using this equation sa ato ang cosine law, kaning mga equation, then the directions, example the azimuth of the lines, and the positions, no, position of the station in the triangle can also be determined. Here are the similarities of the trilateration with triangulation. First is, trilateration network could be the same as a triangulation network. Okay? Since same lang man siya og network, but different lang ang iyang method yung gigamit. So triangulation is ang angles ang directly gikuha, and ang trilateration is ang distances ang iya pong directly gi-measure. It consists of a system of joined and overlapping triangles, no, the same sila, and geometric figures are used in the trilateration are similar to those employed in triangulation. An established triangulation system can be converted into equivalent trilateration network, di ba, since parehas naman sila og network nga gigamit, no? By measuring the lengths of the lines instead of measuring the horizontal angles. So ito kong i-discuss na ganina. And then the baseline must be measured just like in triangulation. No? For example, the distance and direction or the azimuth of the baseline must be measured accurately. No? Same gyapon sila sa trilateration o sa triangulation. Same sila baseline, mas accurately po siya gi-measure. coordinates of one of the stations forming the baseline must be known. And second similarity is all stations must be intervisible, no? And located on highly elevated portions of the terrain para mas makitaan siya. And towers or platforms are also used when there is a necessity to elevate the instruments, observers, and signals. For the definition of trilateration network, so when we say trilateration network, it is a network that consists of a system or joined or overlapping triangles or polygons in which all the lengths are being measured. No, pasabot niya is all the lengths, kay trilateration man from the word itself, all lengths are being measured and only enough angles or direction are observed to establish the azimuth. So ang kaning sa enough angles may be isa ka azimuth nga consisting of direction, or for the computation of the position of another station, and maybe one would na horizontal angle, no, for being checked or for checking purposes. So muna siya ang i-observe, no, to establish for azimuth from one station to another station. And para makuha po nimo ang position sa another trilateration station given the position of the previous, no, nga trilateration station. So here are the examples of the trilateration figures. So same ra gyapon sa triangulation, di ba? Mao ni ang similarity sa triangulation o sa trilateration. So sa trilateration, napod siya single triangle, no? Napod siya brace quadrilateral, center point quadrilateral, no? Narang center point. So mainly pare-parehas na siya sa triangulation. Parehas na yun siya rather, no, sa triangulation figures. So another one is the braced polygon, no? Nga naapod siya diagonal, no? Naapod siya baseline, and another figure is the network with center point quadrilateral and overlapping braced quadrilaterals. So we have also figures here for trilateration. So first is the network with 3 braced center point quadrilaterals. And lastly is the network with 3 braced polygons. For the strength of figure for trilateration, let us recall that R is a function of geometric conditions. So nagdepende si strength of figure from the geometric conditions. So below are the values of C, no, or the geometric conditions for the different figures that can be used for triangulation and trilateration. So again, ang pagkuha sa strength of figure or ang process sa strength of figure for trilateration and triangulation is the same lang siya. So below is the values of C for different figures. We have here for triangle, no, triangle sa trilateration, 0 ang iyahang number of conditions or C, while sa triangulation is na ay 1. 1 ang iyang value for C. For braced quadrilateral, no, ang number of conditions or C, trilateration is, ang iyang equivalent is 1, and for triangulation, it's 4. Another figure is the center point pentagon, no? For trilateration, ang C is equals to 1, and triangulation, C is equals to 7. And for pentagon, in trilateration, C is equals to 3 rather, and in triangulation, C is equals to 9. And for hexagon, in trilateration, C is equals to 6, and for triangulation, C is equals to 16. So kung gusto niyo siya makuha ng mga values, so you can use the previous formula that we have discussed, no, sa katong pagkuha sa C or the geometric conditions. I-solve lang ninyo. So here is the formula for the strength of figures. So we have R is equals to D minus C over D times the summation of the change of angle A squared plus change of angle A, change of angle B plus change of angle B squared, no? Or F, no, which is a factor, no, which is equal to D minus C over D, no? And times the summation of equation. So where R is the relative strength of figure, D is the number of direction observed forward and back. So, and that is not including ang fixed or ang known side of a given figure. So, ang pasabot niya class is if there is a line, this one, diyang isa ka station, if it is observed, from, let's say for example, this is A and this is B. So, from station A to B, gi-observe na siya, then so as B to A, gi-observe po siya. So, duha na siya, counted na siya as 2. And C is the number of geometric conditions to be satisfied in a given figure. And F is a factor of computing the strength of formula, which is equal to B minus C over D, where change in A and change in B is the tabular difference for 1 seconds. So, kabalo naman mo sa pagkuha ning tabular difference in 1 seconds. Kaya ito na nang i-discuss sa previous part of this lecture. Where ang kaning change of A and change of B is expressed in units of the 6th decimal place, na dapat naka 6 decimal places siya, corresponding with the distance angles A and B of a triangle. Naman tayo i-discuss last time atong si distance angle A and distance angle B. Ang change, tabular difference of 1 second sa distance angle A is kaning gitawag nato nga change in A. And ang tabular difference of 1 seconds for distance angle B of that triangle is also the change in B, where the summation of change in A squared plus the product of change in A times change in B plus change in B squared is the summation of values for a particular chain of triangle through which the computation is carried from the known side to the unknown side, which is required and to be computed. So for computation of C, which is the number of geometric conditions to be satisfied in the given figure, here is the formula. So it is the n prime minus s prime plus 1 plus n minus 2s plus 3, where n prime is the number of lines observed in both directions, including the fixed or known side in a given figure. So kaganina sa D, it is for the number of directions nga kung tahay natay station A, and this is the station B. Tapos natay from station A ato siyang i-observe going to station B, and so as station B going observe to station A. So na ang iyang D ana niya is 2, diba kaganina. So, pero sa n prime is 1 na lang siya. Number of lines lang gipangita ang gi-observe in both sides. But again, including the fixed or the known side. Where ang s prime pod is the number of occupied stations, and n is the total number of lines in a figure. Total number of lines lang sa n prime is number of lines observed in both directions, while si n is just the total number of lines. And S is the total number of stations. Since R, or the strength of figure, is a function of a number of conditions in a network, one disadvantage of pure trilateration is that there are not as many as conditions possible can be found in triangulation. So dili siya daghan, iyan na kadaghan ang conditions or possible conditions na makita nimo sa triangulations. Or mo ni ang murag disadvantage kumbaga, no? And a chain of a single triangles is not a suitable configuration for control point establishment and densification by trilateration. Again, chain daw kuno of single triangles is dili siya suitable, no, for establishment of and densification of control points using the trilateration. So dili siya suitable si chain of single triangles. And for a triangle, na ay 2 stations, example A and B, duha ka station, station A and station B, forming the baseline is fixed, no? Fixed, dapat na-measure na siya, dapat na-measure na siya accurately. And 2 distances A and B, no, are measured to fix the determined position of C. No? Dapat inga na siya kung mugamit magaling taog single triangles, dapat ang duha ka station are being fixed, And the distances A and B are dapat na measured siya accurately to fix the position of C. And there must be an extra measurement or no conditions or redundant information to provide a check on the network. For example, to check the calculated position of C. So, dapat napod tayo pang checking or extra measurement kung mugamit ta og single triangle for trilateration. For the choice of figure of for trilateration, theoretically, a pentagon or hexagon would be an ideal figure for trilateration. So, unlike sa triangulation, di ba, perfect square o perfect na or equiangular, no? Equiangular nga triangle. Pero for sa trilateration, si pentagon daw and hexagon would be an ideal figure for trilateration. But ang iyang limitation is establishing even a single pentagon or hexagon in the field would be an almost impossible task, diba? Magisod magitagkuha sa perfect na square o perfect na triangle, so usa na lang kaning pentagon o hexagon. So nai-recommend na mga figures for trilateration. This is the braced quadrilateral, a center point quadrilateral with an additional measurement, and the center point pentagon with an additional measurement. So, kano sa man ta mo gamit og trilateration? So, it states here that ideally, so trilateration is suited when there is a need to establish or densify control points. Example, on a large engineering projects or surveys of wide metropolitan areas. So, kung extended na kayo siya over a large areas, then si trilateration is being employed. For the procedures for establishing a trilateration network, so ang iyang process is similar lang sa triangulation. First is ang planning, next is fieldwork, and lastly is ang computations. For planning, it involves the activities of reconnaissance and selection of station locations. So, dapat ang i-consideran is ang triangles within the proposed figures of a network should contain no angles less than 30 degrees. So, same ni siya sa kato ang limitation nga ato ang i-discuss sa triangulation nga dapat ang mga angles ang murag pinaka suitable or pinaka essential na value for angles nga ato ang i-measure is dapat mas duol siya sa 90 degrees. And for planning, we have strength of figures calculations. And for the field work rather, so it involves the activities of measurement of baselines, erections of signals and towers, measurement of distances, astronomic observations and checks. And for computation, it involves of office computations, reduction to sea level, determination of x and y coordinates of trilateration stations. For the measurements in trilateration, an electronic distance measurement or the EDM equipment is being used. Nowadays, EDMs are integrated with a digital theodolite resulting to a total station. So in short, ang ato ang ganito sa pagkuha sa measurement, labi na kay or mo'y pinaka the best nga ganito karon, no, for measuring the distance is this total station, no? Okay, available po taani sa to equipment, so ano na natong gamiton. And EDM requirements has a measurement range needed for the trilateration job, so dapat maka-compute siya og distances and makakuha po siya og angle. Must yield a standard deviation and measurement lengths suitable for precision required for the control to be established. And EDM should be calibrated on a regular basis. So, si EDM is dapat every 3 years is i-calibrate siya. And the distances measured by EDM must be corrected for all systematic instrumental errors, effects of atmosphere, and effects of atmospheric conditions. Alright, so another notes for the measurement of trilateration is slope distances measured by EDM or electronic distance measurements must be reduced to horizontal distances. It means to say that it must be reduced to ellipsoidal distances when the work is for geodetic control establishment. So let us recall in our geodesy class, specifically in geometric geodesy, no nga, if you are doing with the geodetic surveys or specifically establishing geodetic control, labi na kay ang output ana niya is ang horizontal coordinates, no, or horizontal distances. So ang pinaka-suitable na earth model is ang kaning ellipsoid or ang ellipse, no. So therefore, in measuring the trilateration, so we need to convert those distances nga atong na-measure into horizontal distances that must be reduced to ellipsoidal distances. And additionally, the zenith or the vertical angles from both ends of the lines or elevation at the ends of the line must be obtained also. And for a given area, the separation between the geoid and ellipsoid must be known, and to allow, no, the reduction of all distances to the ellipsoid. O kanang itawag na itong separation between geoid and ellipsoid. So let us recall sa itong geodesy, no, na siya ang N or ang kanang geoidal undulation. Alright, so let's try to solve this example, no, in trilaterations on how to calculate what is the process on calculating the trilateration problem. So it states here that in the accompanying figure, the length of the side of a triangle ABC as measured with an EDM measurement are AB, no, to be 923.245 meters, BC to be 517.328 meters, and CA to be 896.126 meters. The distance measurements are free for systematic errors, and the azimuth of the line CB is 340 degrees, 15 minutes, and 20 seconds. And the coordinates of the station B are 10,150.022 meters and 9,450.085 meters. We need to determine the following: the interior angles of the figure, and the azimuth of AB and CA, and the coordinates of A and C. To solve is we need to illustrate or draw the figure, no. So ingani ang forma, so ABC, then ana po siya labels na corresponding distances, no. So na AC, AB, and CB. First is we need to determine the interior angles ng kaning A, B, and C. So given kanya naman tayo tulo ka distances, we can now directly get the value of the interior angles A, B, and C. So first atong kuhaon is ang distance angle C. Kani first atong kuhaon kani si angle C. Line color. Yes, kani si angle C. To do that, we need to have the formula for the cosine law. So ato lang dayon siyang ako lang instead na katong C squared is equals to A squared plus B squared minus 2AB cosine C. Ako lang siyang gilargo og kung unsa iyang corresponding length. No? From this figure, we can say that to get the angle C, we have this formula. So the distance AB squared is equals to AC squared plus BC squared minus 2AC times BC cosine the angle C. So substitute all the values nga itong nakuha diri nga given, no, from the figure. We can have the value for cosine C is equal to 0.235432422. And to get the angle, kabalo naman mo sa pagkuha sa angle, no, so cosine inverse lang. So we can have the value for C to be 76 degrees 22 minutes and 58.4 seconds. So next is to determine the angle A, no. So kaganina si C atong gikuha, karon na pud si angle A kani siya. To solve that, we have from the accompanying figure above, so we can say that to get the angle A, we need to have this formula, no. CB squared is equals to AC squared plus AB squared minus 2AC times AB cosine the angle A. So substitute all the values nga naa sa taas. So we can have the value for cosine A to be 0.8387050198. So to get the angle, so cosine inverse lang ana nga figure na value, so you can have the value for A to be 32 degrees, 59 minutes and 46.9 seconds. So mo na itong value karon sa A. And lastly is to get the value for angle B. So kanina po natong kuhaon karon si angle B. So from the accompanying figure above, we can say that to get the value for B, we will be going to use this formula. AC squared is equals to AB squared plus BC squared minus 2AB times BC cosine the value of B, cosine B. So, substitute all the values nga naa sa taas. So, we can have the value for cosine B is equals to 0.3318197071. And to get the value for B, cosine inverse sa B lang, so you can have the value for angle B to be 70 degrees, 37 minutes, and 14.7 seconds. So, siya ang value for angle B. Alright, so next thing that we should do to another required no nga kipa-solve sa tuwa is ang pagkuha sa azimuth, no. So first is ato ang kuhaon ang ato sang i-solve unsaon ang pagkuha sa azimuth C to A, no, or azimuth of the line CA. So we have here the given figure no sa ato ang given ka ganina no sa kaninga problem. So gihatag ganina daw nga ang azimuth daw kuno fra azimuth daw of the line CB kani siya CB is to be 340 degrees 15 minutes and 20 seconds. And naapod tay nakuha ganina nga value sa angle C, no, angle nga C kaning 76 degrees 22 minutes and 58.4 seconds rather. So ang gipangita karon is ang azimuth daw kuno ni C padulong kang A. So kani ang gipangita. So klaro sa tong figure karon ng ang azimuth ni CA, no, azimuth ni CA kani azimuth of the line C to A is just no nga ang azimuth daw ni CB, no, azimuth CB minusan lang nato ni azimuth minusan lang nato siya og angle C nga atong nakuha kanina. So substitute no azimuth of the line CB is 340, 15 and 20. Minusan lang nato siya og horizontal angle C which is 76 degrees 22 minutes and 58.4 seconds. Therefore ang atong azimuth DI, no, azimuth of the line C to A is just equal to 263 degrees 52 minutes and 21.6 seconds. So the next thing that we are going to get is the azimuth azimuth of the line AB. But since wala man tayo makuha nga direct relationship from station A padulong sa B, or wala tayo given from station A padulong kang B, so we need to utilize the given values from station C, no, padulong sa A, then A padulong na din ta sa B. So let us first have the given nga mga values. So first is ang azimuth C to A, which is 263 degrees 52 minutes and 21.6 seconds. So out from that given value, so we need to get first this the value of sigma, or kaning sigma. So from the illustration, we can have sigma is from the north padulong sa station A. So wala siya si sigma. To get the value for sigma, we have the azimuth of the line CA. Minusan na nato siya og 180 degrees. Kaya di ba kay since from south padulong sa north is 180 degrees na siya, 180 degrees. So 263 degrees 52 minutes and 21.6 seconds minus 180 degrees. So natay sigma nga 83 degrees 52 minutes and 21.6 seconds. So, from here, from station A na punta, focus na to siya sa station A. So, si sigma karon is equal siya sa south na pod padulong diriya sa station A, C. So, kani nga value sa sigma equal na siya sa value ani niya. So, therefore, from A padulong sa B, natay nakuha gay nga value nga A, no, which is the horizontal angle A. So kani siya kung lang yung color. So kani no siya si A, no, from horizontal angle na siya, no? Horizontal angle A. So we need to determine the azimuth. So ang azimuth karon ni A padulong kang B is kani, no, ato i-project ha. So kani mo ni siya ang azimuth A padulong kang B. So therefore, from the given illustration above, we can say nga si azimuth A padulong kang B, it's just the sigma minus the horizontal angle A. So substituting the value, sigma is 83 degrees, 52 minutes, and 21.6 seconds, minus A nga given or atong nakuha kaganina no, from the previous slides. The value na niya sa value sa horizontal angle A is 32 degrees, 59 minutes, and 46.9 seconds. So kung ato na siyang i-minus, we can have azimuth A to B to be 50 degrees, 52 minutes, and 34.7 seconds. So muna na karon ang atong azimuth A to B. Alright, so since nakuha naman nato ang interior angles of the triangle and also the azimuth of C to A and A to B, so next thing that we should do is to get the coordinates of B and coordinates of C and A rather, given the coordinates of B. So first thing is to get this alpha. Ano pamata ning alpha, sir? Again, kay kuhaon man nato ang iyahang coordinates, no? But ano pinalang pa man og bearing? It's because we are going to use that for the calculation of latitude and departure, no? To get the calculation for the coordinates of C and A. So, kung ano to si alpha, no? This is the alpha, the Greek letter alpha, and natay given nga 340 degrees, 15 minutes, and 20 seconds, no, nga given sa which is the azimuth C to B, no, azimuth C to B na siya. So to calculate the alpha, so from the figure, no, and also by the way, ang given pala na itong coordinates is ang station B, which is 10,150.022 meters and 9,450.085 meters. Solving for alpha, no? So from the figure, we can say that alpha is just 360 degrees. Minusan lang na to siya azimuth C to B, which is 340, 15, and 20. So it results into alpha to be 19 degrees, 44 degrees, 44 minutes, and 40 seconds, which is equal na siya sa bearing, no? Bearing to BC. No? Okay. Since kung mao ni ang alpha, therefore sa station B equal po na siya diri sa kaning part, no? Which is ang alpha gihapon. So from north lang siya, then diri sa C, station at C, from south siya. So therefore kay si B man ang ato ang given coordinates, so we need to determine the bearing from B to C para mahatagan na to og coordinates si C. Sabtan na ninyo guys, no? So ano lang, subay lang mo sa ako, no? From B to C, kay since si B is naa siya given yung coordinates, so we need to get the bearing sa B padulong sa station C. So which is, kaninga part is alpha, equal po na siya diri ang part, which is alpha also. So therefore, si alpha di is also our bearing B padulong sa station C. So which is for 19 degrees, 44 minutes, and 40 seconds. But from north man siya, so morning na ay north, and padulong siya sa west, morning siya na ay west. So therefore, ang bearing from B to C is north 19 degrees, 44 minutes, and 40 seconds going to the west. Alright, so since kinatapos na ito kuha ganina, no, ang bearing from B to C, is now we are going to get the bearing of B to A. So, anong sasabi mo kita mag-start, sir? It's because ang given nga coordinates nato is nasa B. No? Mo nang kinahanglan sa B ta mag-base, no? Para makuha na to ang mga coordinates sa A o sa C. For this illustration, no, we can say that A to B is natin na value nga, natin nakuha nga kaninga angle. No? So, ito siyang i-denote as beta. No? So, beta is also equal to this one in the part of the station B. No? Kani siya. So, equal na sila geometrically. Beta gyapon na niya. So, kinsa man ni si beta. So, beta, so para makadumdum mo, kaganina sa ato ang illustration, sa first previous slides, ani nga example. So, balik ta ani nga figure, ang pag-determine nato sa um, azimuth A to B. So therefore, from this illustration, we can say nga from A, station A, mao ni siya si beta, no? So mao ni siya si beta, which is that is equal to the azimuth from station A padulong sa station B, no? And kung nado sa station B, no, mao gyapon ni siya si beta, ani beta gyapon na siya. So therefore, di ay si beta is just the azimuth of A padulong sa B, which is equal to 50 degrees, 52 minutes, and 34.7 seconds. So therefore, ang ato ang azimuth A to B is just equal to beta, which is 50, 52, 34.7. So that is also the bearing of B to A, no? B to A. So from station B, no, since kina base mo sa station B, kuha na to ang coordinates ni station A. So therefore, from station B padulong sa station A, naatay bearing nga 50 degrees, 52 minutes, 34.7 seconds. Kay since kay north siya naka-base, so naatay north, and padulong siya sa east. So therefore, naka-east po siya. As a whole, ang atong bearing is north 50 degrees, 52 minutes, and 34.7 seconds to the east. So next is we are going to get the coordinates of A. And to do that, natay given na distance BA, which is 923.245 meters. So to solve for, to get the coordinates of A, we need to have first the latitude and departure calculations. So for departure, we have this formula. Departure is equals to B sine beta. So beta mo na to ang denote kaganina sa pagkuha sa azimuth from azimuth B to A, no? So substituting the value, departure is equals to 923.245 sine 50 degrees, 52 minutes, and 34.7 seconds. So we will going to result in a departure value of 716.24 meters. And for latitude, we have this formula. Latitude is equals to B cosine beta, no? And substituting the value, latitude is equals to 923.245 cosine 50 degrees, 52 minutes, and 34.7 seconds. So it results into a value of latitude is equal to 582.56 meters. Alright, so positive ang latitude ng departure, okay, since ang ato ang direction for the bearing is north and east. So positive ito nang kinaa sa quadrant 1. No? So manang positive ang departure, positive ang latitude. Next is we need to determine the coordinates of A, no? From the given value of coordinates of B, which is 10,150.022 and 9,450.085. No? So to get the northings of station A, we need to add, no, the northings of B, which is 10,150.022 plus nato ang kaning 582.56, which is ang latitude, no? Kani siya, no? Latitude. And it will result into a value of 10,732.582 meters. No? And for eastings, we will have the value, atong i-copy ang value sa B, coordinates of B, which is 9,450.085 plus, i-plus na to siya kay since positive man, no? 716.24, gikan na siya sa kaning departure value. So it will result into 10,166.325 meters. So this is now the coordinates of A. 10,732.582 and 10,166.325. Alright, so next is we need to get the coordinates of C. No? And we have here a given, no, of D, which is also equal to the side BC, which is 517.328 meters. So balik tayo nga formula to get the latitude and departure or enable for us to get the coordinates of C. So we have here departure of this D sine alpha, where alpha is kato niya itong gikuha kaganina sa previous slides, na maupod siya ang bearing from B padulong sa C. So substituting the value, departure is equals to 517.328 sine 19 degrees, 44 minutes and 40 seconds. So we will be having a value of departure is equals to 174.77 meters. And for latitude, we have here the formula d cosine alpha. Again, alpha is the bearing for side B to C, or station A to C, B to C rather. Substituting the value, latitude is equals to 517.328, cosine 19 degrees 44 minutes and 40 seconds. So we will be having a value of latitude is equals to 486.91 meters. And to get the coordinates for C, from the coordinates given B, which is 10,150.022 and 9,450.085. And for northings, just add the northings of B, which is 10,150.022. I-add na to ang 486.91 since kaya nga to ang bearing, is naka-north and west, So naka-northwest man siya, so si north mo na siyang positive ni siya kani, positive, So positive 486.91, we will have a value of 10,636.932 meters. And for eastings, we are going to use the value of the eastings of B, coordinates of B, which is 9,450.085. Ato siyang i-minus kay naka-west, naka-west siya. So minus 174.77, which is gikan na siya dito, And kaning 486 is gikan siya dira sa latitude. Therefore, 9,450.085 minus 174.77, we will have a value of 9,275.315 meters. So again, ano siya ang coordinates sa C? 10,066.932 and 9,275.315. So here are the summary of the answers or solutions for example number 1 in trilateration problem. So we have here the interior angles. Ano siya? Interior angle A 32, 59, 46.9, and for B 70, 37, 14.7, and C is 76, 22, 58.4. For azimuth AB, we have 50 degrees, 52 minutes, 34.7 seconds. And for CA, 263, 52, 21.6. And sa coordinates, we have here the coordinate A, which is 10,072.582 and 10,166.325. And for C is we will having 10,636.932 and 9,275.315. For the adjustment of trilateration data, the observed values in a pure trilateration network are measured in distances. Diba sa mga ang discuss na kanina, na sa trilateration network, ang iyahang data is all measured distances. So enough distances must be measured to provide redundant observations. With redundant observed distances, the best procedure for adjustment is the method of least squares, using the technique of indirect observations. This requires the setup of the distance equations for each measured distance. We all know nga ang distance formula is the square root of the quantity of x1 minus x2 minus x1 squared plus y2 minus y1 squared. So mo na siya ang distance formula. This distance equation will then linearize, resulting to distance condition equations. Each distance equation, condition equation contains measured distances and corrections to the x and y coordinates for the stations of a known position in the network. And the distance condition equation will then be subjected to least squares adjustment to find the values for the correction. But this topic, ang kanilabi ng kaning adjustment of data or adjustment of errors using least squares will be more you will be going to deep in with this topic in your GE 126 or the geodetic computations and adjustments. Alright, so this ends our video lecture, and I hope, class, that this video lecture will help you in um, understanding the subject, which is the hydrography. And if you have any questions and clarification about this topic, you may drop your message in my FB page, no, so that I can answer it directly, no. And again, thank you so much for watching, and keep safe, everyone, and have a good day.